Is this what you got? Okay. Remember, check yourself. Annalise. Okay. If you always cross multiply in this direction and put that answer here, this direction and put that answer here, think of reading a book from left to right. The first sign you come across goes in the first group. Because the product of these two numbers is how I got -6. So one of them has to be minus. And I'm not going to put the minus sign in front of the first term. So if one of these numbers has to be minus, and it's not this one, then it's this one. And if this is how I got the product +2, I need a plus sign somewhere, and I'm not going to put a plus sign right here. So if it's not going to go here, it's going to go there. Okay? But shortcut, if you just remember to do this, what happened? Then you can simply say your first sign goes in the first group and your second sign goes in the second group. Okay? All right. John Bostic, what should we look for first?
Common factor.
A greatest common factor. Is there one? No. He says no.
Yeah.
3. 3 goes into 3, 18, and 24. Okay? So, since I took that common factor out, I've created a simpler trinomial now. Okay? Where factoring is easier. Remember, 3 is a part of the puzzle. It's just out there. Multiplied by the two factors you're going to get when you factor that trinomial.
What if you just do it? If you take the factors of 3 and 24, you still get the same answer.
When you get to the end, you will have one group that's still got 3 and something that 3 goes into. So you'll have to factor 3 out. Okay? So you're going to have to factor that 3 out either at the beginning or the end. If you do it at the beginning, all you got to look for here is factors of 8 that add up to 6. Is that what you got? Or are you not there yet? Eventually, you're going to get so good at doing the little factors for the ones without the number in front, it's going to just be real quick. Okay, when you start to see the pattern. Who's singing? Oh, they're doing the Memorial Day service. Gotcha. First, look for greatest common factor. Is there one?
No.
No. Okay, so you have to go through the whole process here. Factors of 6c squared and factors of 6. And how can you put them together so that those middle terms add up to 13? Okay, now remember, if you try it one way and it doesn't work, just switch the position of one of the groups. Just switch your 2 and your 3 and try again. It does matter eventually. Wait, that's not.
I didn't know how to do it whenever I got home, and now I'm starting to do it.
Oh, yeah, it matters. Try starting with your two factors that are closest together, like 4 and 3 and 3 and 2. and try them out, and if it doesn't work, like, you'll just have to like do 3 and 2, and if it doesn't work, you can switch to 3 and 2. If it still doesn't work, then you can either change this to 6 and 1 or change this to 6 and 2. You know. As you get good at this, you'll start to know how it's going to go. Yes?
I don't get it, because no factor is 6 add up.
Because it's not simply factors of this 6 that we're taking into account. We also have factors of this 6 that are taken into account. Okay? Watch. These are factors of 6c squared. 3c times 2c. Right here. These are factors of this 6. When we cross multiply, I've got 9c and 4c. Now do those add up to 13? Does 9 plus 4 add up to 13? Yes. And to get plus 13, they must both be plus. Annalise.
So you're not supposed to see if they add up to 13 until
After you cross multiply. After you cross multiply. Okay? All right. Start talking about the difference of perfect squares. But to get there, I want us to actually do FOIL a couple of times and see what we get. And then start to recognize the pattern of what exists in these two binomials. This is new. Difference of perfect squares. Okay? This is what we're going to try to get to. But I want to show you how do we get from here to the difference of perfect squares. All right, well, let's do FOIL to put these two things together. First times first is x times x. Outer times outer is negative 2x. Agree? Inner times inner is plus 2x. And last times last is minus 4. What happens when you put those two middle terms together? They zero each other out. So you have no middle term. Right? Let's FOIL this together. X squared minus 6x plus 6x minus 36. Once again, there is no middle term. It zeroed itself out. What do you notice about those two problems that we started off with? The groups are exactly the same, except one is plus and the other one is minus. See, x and 2, plus minus. x6, plus minus. And what do we get in the final answer? A perfect square. The square of x and the square of 2. And it's the difference between these two numbers. Okay? Because we have to subtract 2 and 2 to make 0 here. And we have to multiply negative times positive to get that negative there. Look. X squared, 6 squared, and it's subtracted. This is the easiest form of factoring. Because after we look for a greatest common factor, if we see that we have the difference of two perfect squares, then all we've got to do is figure out what the square roots of those numbers are. X and 4. Because it's going to be x and 4, but one's going to be plus, and the other one's going to be minus. Factoring